We are going to see about deadlocks. Okay, first of all, we'll see why deadlocks occur. Before we know that every process requests resources for it to execute completely. Suppose you want to print something, that is also a process, right? You need to allocate the printer resource. So this is nothing but allocating resource. This is the duty of operating system. So there might be shareable or non-shareable resources. Example, printer. Printer is non-shareable, right? At a time, 2-3 processes can't print simultaneously. So printer is non-shareable resources. Like that, shareable resources also exist. So a process in operating system uses different resources and uses resources in the following ways. So a process might does not require only single resource, right? It may require multiple resources. So the process is as follows. First, it will request a resource, then the resource will be allocated if available, then it uses the resource, then it releases that resource. Now we'll see about deadlock. Deadlock is a situation where set of processes are blocked because each process is holding a resource and waiting for another resource acquired by some other process. So suppose, consider this example. There is a process P1, process P2, resource R1, resource R2. P1 is holding the resource R1, P2 is holding the resource R2. Now P1 is already holding resource R1 but is requesting for R2, which is being held by P2. Now P2 is waiting for resource R1, which is held by process P1. This situation is known as deadlock. There are some practical examples that you can imagine to understand the deadlock situation. For example, consider this situation. Imagine a four-way road junction. It will be kind of like plus symbol, right? In this plus symbol, everywhere you imagine vehicles. So there won't be any way for the vehicles to move in order to clear the traffics. Like every way is blocked. The vehicles won't be able to move. So that is a deadlock situation. Another example you can imagine is, imagine only a single track. In that single track, two trains on the same track are moving towards each other. So, and there is only one track. They are facing off each other and there is only one track. So they can't move anywhere else. If they face off each other, there might be a point where they collide, but they can't move anywhere. They have to stop. That is a deadlock situation. I hope you understood what is deadlock through these practical examples. Now I'll illustrate deadlock with respect to processes and resources with the help of resource allocation graph. This is a resource allocation graph. Here we are imagining that resources are single instance based. Now in this diagram, resource 1 is assigned to process P1, resource 2 is assigned to process P2, but P1 is waiting for resource 2 but it is already having R1. P2 is already having R2 but it is waiting for R1. So here you can understand that deadlock like situation is happening. Another example, this is two process based, right? There might be many process based also. See this example. P1 is holding R1, P2 is holding R2, P3 is holding R3. But P1 is waiting for R2, P2 is waiting for R3, P3 is waiting for R1. So this is deadlock situation only, right? So this is all about deadlocks. I hope you understood deadlocks through these practical examples and resource allocation graphs. Thank you.